Alrighty, in this section we're going to be talking about data sets for deep learning. One of those data sets you've already encountered is the MNIST digits that we're looking at right here. So we used those in lesson 1 to train our neural network, and then we talked about them a fair bit at the beginning of lesson 2. So these are equal samples of each of the digits 0 through 9, and these digits were drawn by earnest US Census Bureau employees and high school students. So they just hand wrote digits 0 through 9 until we had 60,000 training images and 10,000 test images. As we've already covered, those are black and white images. The only color dimension or darkness dimension is the darkness of each pixel, and we have 28 by 28 pixel images for a total of 784 total pixels on each image. The Oxford Flowers dataset is, you can see even from this slide right here, that the data are quite a bit more complex than the MNIST digits. So these images were curated by the Visual Geometry group at Oxford. They built a neural network called VGGNet, now popularly, that is the most complex neural network we'll be building in these live lessons, and we'll be using that big VGGNet to distinguish flowers from the Oxford Flowers dataset. There is a smaller set of images with 17 categories of flowers and a larger one with 102 categories. We'll be starting off with the smaller set of 17 categories, and you can move on and try the larger set. I'd recommend doing that as an exercise. Each category, whether we're talking about the small set or the large set, has 80 color images in it. And we'll be using this shortly, so get used to these flowers. I think we have some buttercups here, some dandelions. I'm not very good at distinguishing flowers. Networks tend to be better. They had a lot more training data than I do. The next data set we're going to talk about is the CFAR data sets. So CFAR stands for the Canadian Institute for Advanced Research that funded the work. These data sets, the small one has 10 categories, the large one has 100 categories. They were curated by researchers at the University of Toronto, so on Jeff Hinton's team, with this project led by Alex Kraszewski. And Alex, you may recall his name. His name is on AlexNet, which is the one that we discussed in lesson 1 that in 2012 showed the machine learning community that deep learning was something that they should be paying attention to. So you can see the 10 categories from the CFAR 10 dataset here: airplane, automobile, bird. You'll note that these images have quite a bit more diversity than you could get in pictures of flowers. And so to be able to do any kind of classification with these images, we have to have far more images. So the flower dataset had 80 images, and the CFAR dataset has 6,000 images per category. So there's 5,000 images in each category for the training set and 1,000 in the test set. The CFAR 100 dataset is the same thing, just 10 times more categories. So instead of 60,000 images total, there's 600,000 images total in the CFAR 100 dataset. Finally, the biggie, the really big one in machine vision is the ImageNet dataset. So the ImageNet dataset is so big that it wouldn't make sense to store all the images individually. Instead, it's a list of image URLs on the internet, 14 million URLs, and those are annotated to within 22,000 different categories. When people talk about using the ImageNet dataset, often they're talking about using it in the ImageNet Large-Scale Vision Recognition Competition, or ILSVRC, a mouthful for short. And that subset is simply 1,000 categories from the larger 22,000 ImageNet dataset. And amongst those 1,000, they deliberately selected 120 of them to just be dogs, because dogs are relatively similar looking, and so training these neural nets to be able to distinguish between breeds of dogs is quite a complex, fine-grained task. And to illustrate that to you, I have here a picture on the left of a Yorkshire Terrier, and on the right It's an Australian Silky Terrier. Now, I bought a beautiful Yorkshire Terrier puppy earlier this year, or so I thought, until 5 months later, I discovered that in fact it was an Australian Silky Terrier, because to me, I can't tell the difference between these things, but the neural networks that are trained on the ImageNet dataset can. So it's an example of a computer of these neural networks exceeding human performance on a task. And finally, although machine vision is the focus of our live lessons here today, to have a relatively constrained task to solve, when you're done with these live lessons, you may be interested in applying neural networks beyond machine vision datasets. And so I've curated a sort of meta list here at johncrone.com/resources of lists of open and publicly available data sources that are designed for deep learning.